Let's try to solve this one, see what we can do with it here. I'm going to start by naming the equations so I can find them easily. I'll call the top one number 1, bottom one number 2. And let's start out here. I want to eliminate y and get x. Now, I just like to eliminate y and get x. If you want to start by eliminating x and get y, we all end up in the same place. So I'm going to eliminate y and get x. And here's my plan. I'm going to look at these coefficients of y, and I want them to become opposites. So I'm going to look for the smallest number that both of these coefficients divide into, and that's 6. They already have opposite signs, so I can make them 6s if I multiply the top one by 2, the bottom one by 3. So that's the strategy. Here's how I'm going to do it. So how about 2 times equation 1 plus 3 times equation 2? That notation makes sense? 2 times equation 1, so 2 times that entire equation, and then add 3 times that entire equation. So here's the strategy. Let's see it actually happen. Make the multiplications. So pass a 2 through each one of these terms here. So I'm going to multiply 2, 2, 2. So it's going to be what? We're going to get 8x plus 6y equals 28. And then 3 times equation 2. So I'll multiply everything here by 3. So that's going to be a 27x minus 6y equals, this is going to be a 42. Now, when we add these together, that's what this is, right? We're adding them together, and we're using the method of elimination by addition. When we add them together, we get 35x, the y's are gone, equals, well, that looks like 70. So then I'm going to divide. X is equal to 70 over 35. Well, how convenient is that? Just happens to be 2, so now you're just going to feel like you're doing it right. Okay, so we got x equals 2. Now, you know what we could do? I'm not going to do it in this case, but what we could do is, this is a nice integer, easy to work with. We could take the 2, put it back in here, or here, compute, and then solve it for y. But sometimes it's not so convenient, like you might get a fraction here. So what I'm going to do is just do what we did here. We eliminated y, got x, easy to work through. Now I'm going to do the same thing over here, but I'm going to eliminate x and get y. So focus in on these coefficients of x's. I want them to become opposites. The smallest number they both divide into is 36, so I'm going to make them 36s, and I can do that if I multiply the top by 9, the bottom by 4, but because they have the same sign, I need one of them to be the opposite. So instead of multiplying by 9, how about if you multiply by negative 9? So here's the plan. Negative 9 times equation 1 plus 4 times equation 2. And here's what it all looks like. If you multiply a top equation by negative 9, you get negative 36x minus 27y equals negative 126, right? Negative, because I'm multiplying by negative 9. So I just multiplied negative 9, negative 9, negative 9. Got me here. Now, multiply through the second equation by that 4. Everything gets multiplied by 4. So let's see, we'll have positive 36, and those x's will go out when we add them. So I'm multiplying by 4, so minus 8y equals, that's 56. And when we add these together, the x's go out, right? Negative 36x plus 36x is 0x. The x's are gone. We get negative 35y equals, well, negative 70. You divide. Y is equal to negative 70 over negative 35. So what do you know? Y is equal to 2. All right, so let's just now claim that our solution is this. X equals 2, y equals 2. Or, if you like, you could write it as an ordered pair, 2 and 2. And visually, what you're saying is that if, back up here at the original, if we were to graph this line here and this line on the same coordinate system, that they would intersect. Where would they intersect? Right at this point, to the right 2, up 2.